And welcome everyone to this webinar, the Iliad webinar in the Iliad Hackathon. Today we are going to talk about immersive ocean digital twins using Unreal Game Engine. My name is Bente Lilia B. I'm representing Iliad, the innovation manager, and also co-organizing this Iliad Hackathon. I'm very pleased to see you here. We have a very exciting program today. I will show you even though it's very simple, I will show it to you so that you get an overview. And before we start, so this is the agenda, a very short welcome from me. And then we dive into first a little bit of context on twins and an introduction to the procedural ocean. And then we will see some practical use. We will actually have some live demos today. So this will be super exciting. Our speakers, our experts come from the Breda University of Applied Sciences, and you will learn more about them. Igor Meyer, professor, and Joey Rilo, a 3D artist, in short. I think, yeah, so questions, please do ask questions in the chat as they are arriving in your head. We will also allow you to ask questions in between, and we will have some Q&A. So in between and towards the end, we will take that on the fly, I think. And yes, please do engage with us. And I think we can get started. We will record. This is, of course, recorded, and those slides will be made available. But of course, the live demo, you have to be able to play with the engine yourself if you want to reproduce that. So, Igor, I give the floor to you first.
Thank you very much, Bente, for your words of welcome, and also on our behalf. I wish you a warm welcome to this webinar. I'm very excited that we have an opportunity to show the progress and the different developments of I think, a very exciting project that we're working on. We gave it an exciting title also, which is Immersive Ocean Digital Twins using Unreal Game Engine. So I'm sure that people who feel a connection with the world of gaming and immersive media, like virtual reality and augmented reality, should be very excited. And if not, this is your opportunity to learn what we can do for it, with it, for, in this case, taking good care of the ocean by developing digital twins. Now, this presentation today will actually consist of several parts, and I think it's appropriate to maybe just spend a few words about ourselves, not because we're so super interesting or something like that, but it explains also the perspective on how we look at digital twins and where we come from. Both Joey and I are already working on several developments using advanced simulators and especially also games for understanding the ocean better, but definitely also for contributing, for taking care of the ocean, both from the ecological perspective as the human side. Joey and I work at Breda University of Applied Sciences in the southern part of the Netherlands. And more interesting is that we're both very passionate about everything that has to do with digital games and digital media, especially also for non-entertainment. And for non-entertainment, it means that, of course, we do like games and we play games. Joey possibly a little bit more than I do, but we're especially looking at the use of games for non-entertainment purposes. So games that are not only there for fun and engagement, but how we can use them to make organizations or systems learn and improve. And in this case, the topic of today is, of course, the ocean governance, marine spatial planning, and so on. So in this case, applied to the topic of today, it would mean, what can we do with game technology, game design, both the creative aspects, immersive media like virtual reality and augmented reality for ocean digital twinning. We are both also Iliad digital twin of the ocean partners. And if you want to find out more about our track record and what we're doing, other exciting projects, I welcome you to visit the website. I'm sure you can Google us and find more stuff. But today we're talking about developments in the context of Iliad. I'm sure that many of you through the website, you signed up for the hackathon, you are pretty much aware on what Iliad is. But just a few words of introduction. Iliad is an EU flagship project, so funded by the European Union. Started a couple of years ago with a runtime of about 3 to 4 years. And it's quite considerable. It consists of about 50 plus partners. And we have a wide range of activities and work packages looking at several aspects or many aspects of what it means to create a digital twin of the ocean. So we're not talking here about one digital twin for the ocean. No, we're talking about here of an ecosystems of digital twins that work together and many different modules that form this landscape, this ecosystem of digital twins for the ocean. And we're pioneering and making innovations in all kinds of aspects of what it means to develop digital twins. A bit of context here. Why are we here? Why maybe you signed up? Well, this is actually also an open invitation. It's really an open invitation to join the online hackathon. But also, I hope we have an opportunity to possibly meet in Oslo, where there will be a 2-day hackathon on the 11th and 12th of September, where we can together see how we can make progress in all the different innovations of digital twins that Iliad is working on. And today, we are talking about using immersive technologies and game engines like Unreal and a sophisticated AI technology called procedural generation. And the challenge actually for you and for all your people in your network is help us to make the ocean, immersive ocean digital twin even better than it is today. So the purpose of today is to show you where we are and where the opportunities are for further development. And if you like it, and if you think you have the expertise, please contact us, contact Bente, sign up through the website, work over summer online, or come to Oslo, meet us and work in the digital twin of the ocean immersive environment. So this is the open call. Iliad is not the only project working on digital twins for the ocean. There is a large number of projects under the EU Horizon projects that are working on digital twins. And together we're developing a digital twin infrastructure. But here, for instance, if you look at the DITO projects, you see already the European Commission is fully committed to building a European digital twin of the ocean, and so on and so on. But there in yellow, I marked to create a virtual representation of marine and coastal environments. So apparently, we're looking here at virtual representation. What does that mean? How do we create a virtual representation? What type of technology? Is it only technology, or is it maybe also game design? Does it also involve creative aspects? Does it involve user interaction and how to create that? That is exactly the topics of our expertise and where we're looking. Now, very, very quickly, what is a digital twin? I'm sure that many of you have seen examples like this before. A digital twin is actually a digital virtual representation or copy of something that exists in reality. And I always find this picture very illustrating. So if you imagine that the real world is full of reference twins, or maybe the real world, like the ocean, is a reference twin by itself, we can break it down in actually two aspects. One is called the attributes, so all the parameters and the variables that are associated to the reference twin. And the second one is the rules of behavior of that reference twin. And then we go through a design process. The first thing we need to do is translate the attributes into data, and then develop the algorithms that sort of simulate the rules in the reference twin. And then we go through a design process for design and validation. But if we have it and we think we're pretty close, then we're going through another cycle where we need to use the digital twin for making decisions and actions and the right decisions about the reference twins. And then we also need to check and monitor and control if the reference twin is giving us the right information and if we're managing the reference twin by itself. Now, I think that the gaming aspects, because that's the topic of today, comes in, actually, because we don't do this only in an engineering perspective. Gamers also look at players or users. If you look at this as a multi-actor or a multiplayer game, you will see that this system that we designed by itself as a digital twin is full of stakeholders, and stakeholders are players. They need to interact with the reference twin. They need to interact with the digital twin. They are involved in the design process. They're making decisions. They are looking into the monitoring and so on and so on. And as soon as we put humans into the system, we get humans in the loop, and humans in the loop, we know from theory, are actually games. So we might need game design and game technology in order to understand that actually what are we engineering and how are we using it. So that is where we come from. Also looking at the Iliad scheme, I don't expect you, if you haven't seen it before, to get this at once, but here, the front end, there is where BUAS and all the partners in our Iliad work package 6 are working. We're looking at the user interaction with the models. We're looking from our game design expertise, how can we create playful interaction? How can we work with challenges, with dashboards, with interactions? And then we also look at the technology, which here is mentioned as virtual reality, augmented reality, mixed reality, and working and interacting with maps and how are maps related to that user interaction and virtual reality. And are we working in 2D? Because you know games can be 2D, but games can also be 3D and fully immersive. So that is the design space where Joey and I are working. Now, to take you a little bit back on our expertise, I want to show you and running maybe some examples of what our students, and you have to realize these are our first year bachelor students, and this is a show reel of recent graduation work of their first year. And they're working with advanced game technology, game engines like Unreal, virtual reality. They work with virtual productions, so green screen type of systems where they can create blends between real animations and real acting and the virtual world. Joey, maybe you can explain a little bit on what we're seeing here and how this connects to the topic of today.
So the students are responsible for creating their own 3D models. This is procedural generation, which means that you generate things based on a rule set. They do simulations, so VFX for either movie or video games, so that the engines get stronger. We have particles and lighting that they have to real-time show in engines, and of course, small digital twins, for example, remote controllers. This is one about physics. Program the way that everything bounces on each other and interacts with each other. It's a very quick overview of the different skill sets needed.
Now, just as a frame of reference, this is what first year bachelor students, so you have to imagine that last year they were still working in their middle school. They enter our game school and they pick up these skills with fast lightning and are able, with our coaching, to develop actually to work with physics engines, with game engines, create blends between digital media and things, and to start prototyping. And if you see what the physics behind this technology can do, then the question arises, if we take it a bit further, so in the advanced level for our challenges like digital twins of the ocean, what is possible? Now, the game technology industry is looking with great interest to these developments. And then connecting it to the topic of today, the Unreal game engine. This is just a snapshot on how Epic Unreal advertises. They're not developing game engines anymore. No, they're developing engines for digital twinning. And there you see that they also already cross over to non-entertainment for architecture, real estate, and the built environment. Not ocean planning or ocean twinning yet, but they could easily add to this topic for the ocean or for ocean twinning. And maybe after this hackathon, they are fully aware of the amazing stuff that we are doing. And maybe in the near future, we will have a comma behind it, and then we're added to it. Now, anyway, then with the immersive reality, also in the entertainment sector or the infotainment sector, you see that there is a multitude of applications that are trying to find these crossovers between game engines, game development, immersive media, and the ocean. And this is just a couple of examples, illustrations already from a few years ago. I try to reference them as good as possible. But if you Google, I'm sure you can find many, many, many more. On the left corner, you already see an amazing project where they laser scan real-life corals. I believe that the Smithsonian Institute in the United States is already developing digital twins of corals where people from all over the world can actually, scientists or real or ordinary citizens can just see them in immersive realities on their screen. And I think the impressions that you see here with other types of technologies are already clear enough. So this is where we're heading and what is already possible today. Now, coming back to our topic again, Joey and I are already since 2011, so about 14 years, working on the exploration on what we can do with game technology for understanding the ocean, and especially also for helping marine spatial planners, so people in charge who work for government and need to make planning decisions on what to do for the ocean, where to allocate the different ecological and human functions on our sea. And this is actually has been for the last 10 years mainly in 2D, so working with geoinformation systems where multiple stakeholders who have a formal position as marine spatial planner, and to support them into their transboundary collaboration for making maritime spatial plan, working with the real data. And I can quickly show you an illustrator on how that works in 2D.
The MSP Challenge Simulation Platform, the next generation of maritime spatial planning support. Human activities at sea easily get into each other's way and have a long-term impact to the marine ecology. Therefore, countries around a sea basin have to coordinate and balance interests or face the consequences. The MSP Challenge Simulation Platform helps planners and stakeholders understand and manage the complexity of maritime spatial planning. In the interactive simulation, country planners view the entire sea region and review many different data layers to make an assessment of the current status. They develop plans for future use of sea space over a period of several decades. The consequences of decisions for energy, shipping, and the marine environment are simulated and visualized in indicators and heat maps. The MSP Challenge Simulation Platform uses the best available data provided by many authorities in Europe, and it has a unique link with the ecological modeling software EcoPath with EcoSim. Digital game technology makes it fun and easy to draw and modify plans, run the simulations, and interact with others. It even has a 3D virtual reality model. This makes it a perfect environment for education, stakeholder engagement, and interactive planning. With additions for the North Sea, the Baltic, and the Clyde Marine region, the platform is ready to host any sea basin in the world. The MSP Challenge Simulation Platform, coming soon to a sea near you.
So I'm showing you a little bit as a context on where we come from. This trailer was produced about 3-4 years ago. So the technology of the MSP challenge, and especially the geoinformation system, has advanced enormously. But at the end of the trailer, you see already an example on where we started to explore already 4, 5, 6 years ago in how to make this immersively interactive. So what can we do with an immersive environment in virtual reality? And the images that you saw at the end of the trailer are 4 or 5 years ago. As part of Iliad, we thought it wise to take this a step beyond. Technology has progressed. There is so much more that we can do. So what we're going to do in this next part, and Joey will soon take over, is to show you actually on how this, what we now call procedural ocean, so how to generate real life immersive environments, 3D environments that are generated from the real data, what we can do and where we are, but also where the limitations are and where you can help us. And this is the next part of the presentation, which will all be about the procedural ocean. And maybe here it is also good to start with a trailer. So let's imagine this is a maritime spatial planner. She is called Sarah or Mai, and she is working with data in the procedural ocean.
We don't hear the voice over of the video.
Wait a moment. You see the video, but you don't hear the sound?
Yes, that's correct. We see
And
the
for
video,
the previous video, you did hear the sound?
no, we didn't.
You didn't? Oh,
No.
you report pretty late.
Yeah, let's see.
I apologize because the other video also had sound. Probably we needed in the slide share already give access to also give this share sound. Oh, then the video, the previous video was not entirely clear. We'll try it again.
Can we click on view?
Here?
Yep.
And then?
Presenting Procedural
Now
Ocean,
you hear it?
a generator
Yes,
of
yes.
3D ocean
Apologies.
environment visualizations, developed by Iliad to construct digital twins of the ocean, helping us to make better plans and better decisions for marine applications. Using some of the best video game technologies out there, procedural content generation, a proven technique of algorithmically generating 3D content that makes sense, the Unreal 5.3 game engine, high graphical realness using state-of-the-art rendering techniques, the MetaQuest 3 headset, a powerful virtual reality headset for a fully immersive experience. Using these technologies, Procedural Ocean visualizes human economic activities, wind farms, fishing, aquaculture, shipping, and more. And it visualizes the marine environment. This includes flora and fauna, fish, mammals, the seabed habitat, as well as the physical environment under different weather conditions. It also allows to visualize the interactions between the marine environment and the economic activities. Procedural Ocean is data-driven. Imagine being able to do all this for any sea area in the EU and beyond. You supply the input. The software generates the 3D output. Need more? With its modular structure, Procedural Ocean is extendable at will. Refine algorithms, add simulations, replace 3D content, and improve content interactions. Is all of this ready? No. We are at the prototyping stage, but we're getting there. Keep an eye on the Iliad marketplace and join us. Procedural Ocean, a generator of 3D ocean environment visualizations for digital twins of the ocean. Presenting Procedural Ocean.
So we stop. Now we go for the exciting stuff, for the tech-savvy people. This was the why. It's very important. But Joey will now take us a bit further into the how.
Yes. If you have any questions at any point, let me know. I am trying not to dive too technical, but let me know if it's unclear. So first off, we have the generative AI versus the procedural generation. We all know generative AI by now. We know Midjourney can create beautiful things, and you can give it a prompt, but it's difficult to control what you get out of it. It relies on machine learning, large data sets. For PO, so Procedural Ocean, we use procedural generation, which means that we can control the algorithmic rule sets that may be needed, which means we can use real data to create real environments, wind farms on the ocean. And it also allows us for more control and more input. The AI bit is definitely not to be ignored. We are looking into how to implement that. And if we would go for a hackathon, that would be also where my money is at. See how to put the AI on top of the procedural generation could be something to explore. For us as developers, we had one big main goal creating this application. It is procedurally create a realistic 3D digital representation of an ocean area based on geodata. So what that means is from the 2D game that we just saw, we get all the real data. So this is all being supplied by governments. And that data we use to create 3D assets on top of that. So by doing that, we had a few objectives. It had to be fully data driven. It had to go beyond 2D and become a full 3D environment with all the controls needed to control that environment. The realism, it should look like it looks in real life, so people get a good idea about the scale, about how big the ocean is, or how small a wind turbine looks compared to that. And how do players find their way into this open world? In order to build that, we broke the game down into several components. So on the left, number one, we have the data pool, which is all the stuff that we get from the APIs, the real weather control, the data from MSP. We had to convert it into something that was usable. So we split it up in number 2 and 3, which is the environmental base and the procedural rule packages. The reason we set that up is that the terrain, the water, and the sky, that is based on real data, and that is always controlled by the same bonds. But the procedural rule packs are set up in a way that if one of them fails, the other ones can always remain and keep on going. This is where you come in. This is where I think you come in. So if you have a certain fish you would like to add, you make a new sea pack. If you have a new turbine you would like to add, you make a new pack. And these packs can be fish, lobsters, boats, turbines, anything that goes with the ocean gets its own pack. People can add it, and in that way you can go open source. So the packs, they are standalones, almost like a DLC in a video game. Another one to explore during a hackathon could be number 4, the UI, the camera, and the controls. How do your players interact with an open environment, an open world? And how do they find whatever you want them to find without going too complicated? Because most of the users are not avid gamers. They cannot remember 20 different controls and buttons and shortcuts and whatnot. So you want to make it in a way that it's friendly, but also deep enough for them to find the complex info. So for the procedural rule packs, we came up with a few ideas. So one of them is the wind turbine. If a wind turbine gets placed into the PO prototype, there is sound pollution. Sound pollution means that the fish will go away, which means that the fisheries have to go somewhere else. And all these rule sets are built into the pack. So next to the 3D models, the materials, the textures, and how to display them, you also have to think about the behavior and how that affects all the other things. The 3D content can be a lot of things. We split them up roughly in 4 parts. 99% of what you want to add will fall under one of these. A bit of an overview there. And then I would like to take a look together into the build. At any point, if you have a question, please unmute, because I'm gonna look at multiple screens right now.
Mm-hmm. Is there any question, intermediate question for clarification or whatever? I think not a question that would trigger a lot of discussion, but maybe while Joey is setting up, there is an intermediate question. Yeah. Is it all clear?
While Joey is setting up, and yes, do please ask questions or raise your hand so that we can have an order of your question. But meanwhile, I would like to. I think it fits to share the results of the poll because we asked some questions about you. And the first question was how you work with the Unreal Unity game engines. And we see that there, except for Joey and Igor here, no one is experienced. But we have one that is learning, and definitely several who wants to learn. And for others, it's probably just curiosity.
Okay.
And then the second question is, do you think digital twins can be like a game? And there's only positive here. Yes, of course, or yes, maybe. So just to give you the ambiance in the in the meeting here. And sorry.
Thank you very much. That's very interesting to see.
Yeah.
Okay, I think Joey is set up now.
Yep. You can see the application now, right?
Yes.
Okay, nice. All right, here we go. So this is the start of the game, and we allow players to choose different data maps of different parts of the ocean. So we have Belgium, Germany, the Netherlands, Norway, the UK, Scotland, and I'm gonna click a random one. We can go with this one.
It's also interesting to see that we mainly focused on the North Sea for this demo. But in the hackathon, if there is people who want to join and are in another sea area, they could develop new packs, new rules, and so on.
So since this is based on real data, in this area right now, it's raining. For the sake of the demo, I shall play God and make it a sunny day. And now I'm overruling the real data. If you want to go back to the real weather, there is a button for it, and back to the real weather we go.
So it's very important to realize that this is a virtual representation of how it now is in that real area.
Yeah. So we are.
And this is not movie, this is not a camera. This is a virtual representation of the weather conditions, the ships passing, and so on in that area.
So we can go take a look. I'm speeding up the mouse a bit, so we're gonna zoom over the ocean. And we have a ferry going across this piece of the North Sea. So the player can go freely roam around and explore the area. We can also click on the ship, and we can see that this is a cruise ship called the Atlantic Harmony. The coordinates of where it's heading, it's a 7-day cruise, where it goes, what it does. There's a whole lot of information. Apparently it's going to the fjords. So the players get a bit of an idea what the object that is selected is doing or what its goal is. And in the back, I noticed some turbines, so we're gonna fly over there. Close the info tab. So this is a typical wind turbine farm. In the middle, we have it's called a transformer station, and this transformer station is hooked up to all these turbines. I can tell there is no wind right now, so since we're already playing God a little, I'm gonna adjust the wind speed so that they start to turn and actually generate some power. Close this one. So now this transformer station is online, it's working. We get some technical specifications of what this is doing. And the nice thing about the procedural rule packs that I was just mentioning, this is all part of that. So when a partner or a client adds an object, let's say a wind turbine or a transformer or a ship, this information is embedded in there. So we get the good, like this is TYC5M. I didn't come up with that name. That is the real name of the real thing. And it's connected to a wind turbine at the Rivercut, the E256. And it explains what the footing of this turbine and what it is doing. It has a lifespan of 40 years, yada, yada, yada. But very interesting for the stakeholders that are working with this stuff. We take a look in the water. We can also see how it's connected up. This part of the North Sea is not that deep. That's why they built wind farms there. And we can follow the cable. Let me move the mouse speed a bit to a workable speed. So we can follow these cables and check out where they're heading. We see the shadows of the wind turbines. We see the fish that live here. even the fish are selectable, and we can see that this is a cod, how big they can be, how old they can become, the way they school.
Can you change visibility, Joey?
Yeah.
The scuba divers among us will know if you have dived in the North Sea that this is actually pretty clear water. So normally, if you go scuba diving in the North Sea, it won't look like this.
Of course, you find a bug.
Okay, now something for the people in the hackathon to work on.
What
Anyway,
we can do, we
just
can,
over.
we can play with the time of day.
Yeah.
And now when we go above the weather conditions changed. What is super nice about the way we set up the tool is that, let me close the weather. We have the energy tab. I can click on the energy tab, and there is the wind farm, the cables, the transformer cables, the noise pollution. Click on the wind farm. Let me drag that out here. And then we have different kind of wind farms available to us. So we can have floating ones. And if we now go in the water, we see that these float literally in the ocean. They are only connected to the seabed. While the previous one, which was a monopile, is just one big beam. We have the helix. We have jackets. And it allows for stakeholders to see the differences, see what they look like above and underwater, and also see how they are being maintained. And then there is this new one that we just added yesterday, which is the waveforms. And these float in the ocean and they generate power in a different way. Same thing, they also come with their own info. And similar to the energy tab, we also have, let me put it back to another one. Close this, let's close all of this. We have this data also for fish and wildlife. So we knew there was cod in this area, can open a heat map. Let me quickly fly up. And then the heat map will show us where these fish live or where they don't live. So in this area, there's a lot of cod. Let's see what the mackerel is doing here. And we see the heat map change. So they live in different areas.
Yeah. What is interesting maybe to realize is that the video that I showed of the MSP Challenge 2D, so the geoinformation system, has a connection with EcoPath. And EcoPath is a food web model. So that generates the heat maps of the interrelation between wind farming and where fish are, so where the entire ecology is, and that is then represented in the 3D environment also. So this is simulated information.
Yeah. Quickly open up a different one. Main menu. As you can see, it goes I'm just using a laptop. I'm not using a super powerful big machine or a server or whatever. This just runs on a laptop. You can choose, and go to the UK now. And the loading times are not too long. See now, live demos is a risk. There we go. And now we're in the UK, somewhere on a different wind turbine farm. The wind turbines are spaced differently over here. We have the shipping information as well. So there's some fishing boats and the intensity, and it also gives you height maps on where these live. This overlay here. See if we can find one. I have to change the weather because when it's foggy, it is horrible to find anything. Of course, because there's a big wind turbine park here, another one there, the ships will not be around here. So there is a chance that there's no ships anywhere in the neighborhood in this one. There they are. Because they're not allowed to get too close to the turbines. So we have a official ship over here. Let's see if there is some audio to this. players get close to a ship, you can have the audio that goes with it. And then this one is dragging up the next arms.
May I ask a question?
Yeah,
Yes.
of course, yeah.
Yeah. So you showed, are you using AIS to identify the boats? Is it real or?
It is. Yeah, it is real.
It's like so you have this. I have this for flight information, and you can click, but it's the same, right? It's actually in real time.
Yes.
You get that data, and then you can, when you click on the box of this different ships, you actually get the real data about it. This is happening right now, and yeah.
Yeah.
So this is apparently called the Fatima.
But it's work in progress, Bente. So this is real, but this is what Joey
Yeah.
explained, is connecting it to the rule pack. So it depends. What data you put into it and how you visualize it, and that is to be further developed and expanded.
Yes.
So for some parts, but Joey knows more, might not be so for demo purposes, but in principle, anything where you have the data, you can connect to it and visualize.
Okay,
Yes, because.
I had also a question on that. So basically, what we see, the ship is now passing by, but we can change the time.
Sorry?
So we see a real ship passing by as it is now, but we can change the time because we change the time of day. Yeah.
Yeah. So the shipping data, there will be different ships and different depending on the data. Yes. So if this would be a ferry, then we don't see a fishing ship, but the actual ferry. There is oil tankers. There is the big cargo ships. There is small maintenance ships in the wind turbine. Look, there's something else. Let's check it out.
But it doesn't mean that the actual ship that is passing by is also this actually looking like this, right, Joey?
No, we have a limited amount of 3D models, of course. We try to get as close as possible. This is a cable laying vessel. So this one actually works close to these turbines. But in the big open ocean, we probably won't see this one because this one belongs to all the cable laying.
In principle, that's possible. If you have an unlimited set of all the ships and how they look like. The question is it relevant if you just simulate the routes and the density and the whatever? Is it really relevant how they look like? Or, but for other purposes, it might be. For instance, for a certain marine species, you want an accurate representation on that species.
And also,
sorry.
And on the ship, I mean, because going along the Norwegian coast, you see there are so many different types of ship, depending on what kind of service they are doing, either to the wind turbines, to aquaculture, to fisheries, offshore, etc. And sometimes, I mean, that was why I was asking, because sometimes you get actually some of the physical features of these vehicles or this boats, right? And it can have or not have an implication of what you are interested in. So just having that information can be. I would assume that this could be interesting in some of the cases actually to have it so detailed.
Where we are now is we demonstrate that all of this is possible, and now we come to the hackathon and future developments. We are creating a platform that allows this. So we're creating the backbone, the infrastructure, the user interaction, and so on. But then the next stage emerges where every user, use case, sector, and so on, if you want to work in this platform, can add its own objects, its own models, its own rule sets, or whatever. So for a user that says, like, yeah, but I need an accurate representation of the ships and so on, please go ahead.
So this is next to the Norwegian coast. They have all these big fish pens for farming. Then you can get in and watch the fish swim in there. And the nice thing about, for us on the technical side, is they stay in. So when I go outside, there is no fish escaping. Little
Yeah.
challenge for us. Yeah. But
Sometimes they do escape, and that will be a use case actually to monitor the escape rate, etc.
Exactly, exactly. And addition is, of course, this is real-time data with real models, and it's kind of like, but if you start intervening, so for instance, what you just mentioned, a risk scenario where sometimes they escape, what if there is a failure mechanism in this thing? Or what if I construct a wind farm in the future? What will happen with the shipping routes or the traffic, the safety of the shipping routes? And there it can also be based on decisions, on the rules. It can generate simulators into the future.
This is the one that always messes me up. So I'm very used to working in the North Sea, right? And if I go down, I will find the bottom. But because we're in the fjord right now, it's endless. If I go down, you will not find the bottom because it takes me 700 meters to go down.
Yeah.
Which is really funny to also see players realize that, like, wait, this level is not working because there's no seafloor. Well, there is. You'll have to go down. We have a bit of shore here, but of course we focus mostly on the ocean. Here's another trawler.
And looking at the time, I see that we are about 10, almost, let's say 50 minutes before end time. Maybe it's good, we're already starting a discussion, Bente, but maybe there's also, I see 3 comments in the chat, and maybe there is questions or comments or suggestions.
Yes, thank you very much. Yeah, so let's open the floor more to those who are less shy than I have been. So I see, well, we can have, I know, Fernando, are you still with us? I think you have a point there. You want to make the point?
No.
You're muted. Yeah.
Oh, sorry. No, I was just saying that the ship that you were selecting was a Portuguese one for the name. Yeah, sorry.
Okay, you saw it was a Portuguese.
Yeah.
Yeah, well, I was thinking, coming from Norway, we know that sometimes some of the ships are in places they are not supposed to be, in fisheries, so you can recognize the exact ship. Also in this actual procedural ocean, facilitate monitoring in this way. To a certain extent, I think, to see if they are moving into areas where that goes nationally and across nations, if the ships are moving into areas they are not supposed to be in. Absolutely. And you get a more visual understanding of what's going on. But I have one, please do raise your hand. And yes, Sadra, you have raised your hand. I give the floor to you. Unmute yourself. Yes.
And it's also nice to have an image. If you can open your camera, if possible.
But we don't see it for some reason.
Yeah, do you see the camera? And
I see you now.
Yeah.
Hi.
Yeah, I'm Sadra. I'm from Bochum University of Applied Science, and we are affiliated with the US project Aqua Infra. Thank you for the really informative presentation. My question is, currently all the projection is focusing on visualization. How this model interact with some scenarios? How would be the interaction of, for instance, the ship movement and the impact on the, for instance, marine life and the fish? How could new interaction and how could the scenario be projected in such an environment? And the other question is, these models are super sensitive to the data, the way I understand it, and how the accuracy of the data would be controlled, whether, for instance, these type of gaming and model use the accurate official data, or for instance, you could incorporate some local data in your projection and scenarios.
Thank you for raising 2 excellent questions. The answer is that, and that's why I started my talk in showing you the MSP Challenge 2D geoinformation system. And it's really important to realize that this is a 3D visualization of that platform. And that platform, yeah, you can call it one of the digital twin platforms. You can also call it a game-based geoinformation system, is based, and we spent about 10 years in connecting it to all data sources in the different regions where we work with. So it has EMODnet data in it, it has satellite data in it. We even have, because we collaborated with governments in all the areas where we work, we have search areas for wind farms and so on. And that is all in our data service for the MSP Challenge. Now, so what this 3D visualization Procedural Ocean uses, one of the data sources that it uses is our MSP Challenge data service. And the MSP Challenge data service does more. It's not a static thing. It allows you to create what-if scenarios. So what players actually do is they start in the now time, but they can create scenarios by actually drawing search areas for wind farms. They can designate marine protected areas. They can manage shipping. They can manage sand extraction and so on. And that data is connected to simulators that calculate exactly what you say. What is the impact of building a future wind farm on shipping and ecology? Because while I'm building it, it generates noise, and noise will have an impact on marine life. But that means that during the construction time, the marine life will disappear from the construction side. But after the wind farm has been built, it becomes kind of like a marine protected area, and the fish will return. Now, these type of simulations that generates information like heat maps, indicators, you will shipping routes changes, and whatever. And that is also a rule pack. That is also decisions and rule. And we can generate and visualize that into the procedural ocean. That is, is that an answer to your question? So the data comes from the official data sources, EMODnet, satellite data, government authorities, Rijkswaterstaat in the Netherlands. We connect it to our MSP Challenge as kind of like the interactive geo database that calculates the impact and allows you to create what-if scenarios. And we use that to generate a procedural representation of what people actually do in 2D.
Perfect, thank you. And one little question, do the player and the user have control over the rules as well, or
Yes.
the rules are solid?
No, the rules can be kind of like unchangeable. The weather, for us, unless Joey plays God, he cannot change. Yep. In the game, he can change it. In this environment, he can change. But if we connect it to a weather data source, or we connect it to a wave data source, or we connect it to a you know, these things, they are fixed. They are just geophysical real-time data that generates the world as it is now. For other rule sets, ecological rules, it's science. You know, science knows a little bit on how marine species respond to things and how the food web works. That is simulated. And other rule sets are completely up to the human decision making. If I decide to make a wind farm, or to choose a certain type of turbine, or to create risk measurements, or whatever, it's a policy decision. So there is different types of decisions that lead to different representations into the 3D world. And you have to, when you start designing and creating this environment, to allow for the representation of all of these different types of decision rules. But in the end, they are all decision rules. And whether you can change them or not is up to the designer.
Hmm. Yeah.
Is that a clear answer?
Yes, perfect. Thanks a lot.
Great. Any more questions? Raise your hand so I can see who is wanting to take the floor. I a little bit, while you were thinking about that, I thought that I should inform you about a summer school, the Iliad summer school, because Joey, you are, well, Igor and Joey, you are showing a lot of windmills, right, in your visualization here. And in the summer, the Iliad Summer School, which will take place at the same time as the hackathon is going on. The summer school is in Cork at the University College of Cork, and they are specialized in renewable energy in the ocean. So maybe this could be a very interesting, attending the summer school and working on, a special case here on you in this team of yours, Igor and Joey, could be an interesting and challenging task with some experts to collaborate with.
Yeah, thank you, Benton. That's an excellent suggestion. Of course, the summer schools are great. The only disadvantage for the summer school is that they are in summer and tend to be during vacation time. But our idea and our mission is, I think you now see, and I hope you also support us in the thing that we are now ready to demonstrate and to convincingly demonstrate what it is and what we have in mind. We're also the most likely outcome is that this is an open source, not-for-profit environment for people to start experimenting with under the Iliad framework. Respecting also previous IP that has to do with the MSP challenge. But from our interest, this can potentially involve so much capacity, resources, time, and so on. And it has so much connections to all of these different sectors that we want to build a community of people who are passionate about this, like to work with game technology, and want to help us, the Iliad, Procedural, Ocean, MSP Challenge community, to take this significant steps further. And if that is under the summer school, we can provide, maybe Joey, you can show the manual and everything. So we have on GitHub, everything is open source. People who know how to do this can go online. We have procedural rule pack guides, so basically how to work with it and what to do with it. Now, also that is under development because we're also limited in time. So we are now in Iliad working on our deliverable. And I'm sure that in terms of having user feedback on if this rule manual is already the best one, and what I hope is in the next couple of years, we can significantly improve and extend this together with everybody who is interested.
Yeah. So you foresee like two different activities maybe in at least. One is to actually test and play with the tool as it is today to give you feedback on guidelines, giving you more examples, etc., that you can use further. And the other is for the super nerdy gamers, perhaps, is to actually also work on the software itself, if I'm not mistaken.
Yeah, it can be both on a conceptual level, like this is what you're missing. Like I would like to have 20 more buttons here because my players need these because of reason X, Y, Z. You could also get an open source version of this application, which looks something like this. And then you're free to add your own rule packs, which was the one that is mentioned in the guide. So for example, if you open a fish farm here, this is, let me open the mesh, this is the 3D model of the fish farm. And if people feel like during the hackathon, they want to give it a go in Unreal to add different models, different interactions, something we missed, be my guest, feel free.
Yeah.
It is
right.
Unreal in itself is one big box of Legos, and people are free to add stuff to it.
And for the people who are not so technical, but you could imagine developing, designing use case scenarios. It could be conceptual on the basis of illustrations, even sketching on what to do with it. One of the challenges for the people who are more in the creative game design disciplines is how to create challenges in order to create more meaning into this. Because you can just say, okay, design a wind farm, but is that challenging enough? Maybe you can add game-like elements so that people explore and understand much better of the ocean world than they would by just straightforward clicking around and navigating.
Yeah.
So there is so many different dimensions where people who are into immersive media, AI, creative design, or from the content expert, the sectors, can bring this a step further. And then the exciting stuff is the interdisciplinary or even transdisciplinary collaboration.
Yeah.
Yeah.
I see. So, for instance, so we have insurance for aquaculture. That's one of the Iliad pilots, and actually designing what would be the scenario, the visual scenarios that will be meaningful for the insurance or the aqua farm managers to actually, to look what would, what kind of sceneries. That's what you mean by designing, right? What kind of sceneries would be interesting to have, visualized in a better way than it is today.
That's one form of design, but another form of design is thinking, if you say, hey, how would an aquaculture scenario look like and what does it need to do? And what type of decisions do I need to make in the system and what do I learn? How do I need to see in a dashboard or in a heat map or in a other thing the consequences of what I've just done? How can I add challenges to how people interact so that they understand more on what aquaculture actually is?
Yeah, right. So what is the scene? So for instance, when you have harmful algae bloom and you have to make a decision on what to do, right? So exactly what kind of information do I need presented in what way for me to fast as possible understand the situation where I either do A or B, like remove the fish or let the fish be in, or,
For example, yeah. And then what does the simulator that needs to be, of course, validated and gives an indication, and maybe there are more simulators. What do the different simulators say under these and these conditions?
Yes.
If you think in a wider perspective, I think there are policymakers or stakeholders or ordinary citizens who have no idea what hazardous or poisonous or whatever algae bloom actually is and how it looks like and how it affects fish. Can I use it to communicate actually on what it is, how it is caused, how to manage it, and what is the impact on the marine life or the fish and even the food stock?
Yeah.
Another idea that Igor had is adding the digital humans to PO, to the simulation. So if I add like a digital human narrative,
that explains certain technical aspects of it. What is a floating wind farm?
And how do you implement that human for users? Like, if the ocean is huge, the problem for me as a game designer with this kind of simulation is, if I look this way, I have kilometers of open emptiness. And for a gamer, if I do not know where to look, go find my wind turbine. So we have to guide the players a lot, so that they have an idea of where to look and where to find it, and that they don't get lost in. Because if you open this game and the first 15 minutes is open water with nothing there, I'm going to lose half my audience.
Yes.
So there is a lot of, I am thinking about, how do I make this interesting? How do I have my players find something in this huge ocean? Because that little fish is so tiny compared to a fjord in Norway.
Yeah. Right.
Now, looking at the time, Bente.
Yes.
I hope that the audience and you find it enthusiastic. I also see that the number of participants is dropping, so maybe people need to run to a next meeting.
Yeah.
I thank you for those who are still here for attending. I hope you notice from Joey and me that we are super excited with the things that we do. And I hope that some of that enthusiasm has rubbed off on you. Don't hesitate to send us a message, or maybe in your community, in your social network, professional network, you know people who are into this technology and want to join. We also have opportunities for internships and people writing a thesis and so on, but this is open for all. We need a lot of hands to take this big step further.
Absolutely. We welcome you, and as you say, Igor, that's a good point. Invite people in your network, even if you cannot do or think you can do this, you may know somebody. This will be like a perfect game to play with and join this exciting community. That's a good point. So we are about to form the teams, just a practicality here now. We are about to form the teams. So sign up for this team. If you haven't done so yet, please sign up for this team. If you did sign up for a team and you decided, well, oh shit, I should also would be interested in joining this, send Igor or me or Tom an email. You find all of this in the links that we have shared with you in the chat now. So please, you have the rest of the week, I would say, to decide on this. And then we get started and spend the summer on and off a little bit. Even if, you know, you are taking summer holidays, I assume you won't be away for like 10 weeks or so. So there will be time to enjoy this hackathon, and particularly this super exciting visualization tools that you just saw. So thank you so much, Igor and Joey.
You're welcome, and
This was
hope to
really
see
good.
many of you live soon again. And well, get in touch. You know how to find us.
Yep, absolutely. Bye-bye.
Yeah.
I will stop the recording. Where do I do that? Here. Yeah.
May I ask a little question, please?
Yes, please.
Yeah, perfect. Thanks a lot. I've already applied for the summer school in Cork.
Oh, did you?
Yes. When the agenda of the summer school would be published? It's I don't think it's.
No, the details, we are working on the details to find the speakers, etc. But as I said, wind, because Cork has a lot of expertise on the wind or renewable energy, that will definitely be one of the topics, but not the only one. We will go through data, you know, the whole value chain, if you like, in the digital twin. We will look at sensors as data management.
Especially data acquisition part is super interesting for me. Then as soon as it is finalized, most probably it would be published soon in the website.
Yes, but I can assure you there will be lots of data, collecting data, finding data, collecting data, and harmonizing data. All of that will be covered. Yes.
Yeah, unfortunately, they are happening together, the summer school and hackathon. But for me, I decided to participate in the summer school. And thanks a lot for the informative webinar. I'm really enjoying the webinar. Thanks a lot.
Yes, Sandra, you are welcome to join also the hackathon at the same time. You can actually combine it. We were discussing it, that you can combine being a part of both the hackathon and the summer school. And in fact, and this is off the record now,